simple play the video.
Yeah.
Okay.
Okay, ma'am. Okay.
Okay. So why SystemVerilog? Okay. So first question, Verilog, as I have explained yesterday, okay, Verilog, it is just like a static kind of thing. Okay, we don't have so many, like in Verilog, so many constructs are synthesizable. Like from design point of view, it's perfect. But if I'm coming from verification point of view, in verification, we don't need our code to be synthesizable. But we need something that can make our code simpler. Instead of writing so many lines of code, if I can achieve this in simple lines of code, then it will be easy for us. So many things, that's why they have added in SystemVerilog. First, we'll go to data types. Hello.
Yeah, ma'am. Yeah.
So in Verilog, we have 4 value data type.
Yeah, right. Yeah.
So 4 value data types that were like 0, 1, X, and Z. 0 for low, 1 for high, X for unknown, Z for your where is not connected. From synthesis point of view, this Z and X has no rule. Okay, because you just think if you are designing something, let you have forgotten to connect it. There is one input, you have forgotten to connect that input. Then during compilation only, it will give you warning that this port is not connected. During compilation, you will come to know that this port is not connected. Like if you are synthesizing it from hardware point of view, there is nothing like X and Z. Z means it is not connected. Like 0 means I will get some voltage, 1 means I will get some voltage, but Z means I will not get any voltage. It is not connected. Similarly, X, this X, it is difficult to capture during compilation. For verification engineer, it is important to capture this X. Okay, so in which situation we can get X? If there is some register rich data type, you have forgotten to initialize. It will give you X. Okay, now let there is one signal that you have assigned at a time to many drivers. That time also you will get some X values. Okay, so during compilation it is difficult to capture, so through verification only we can capture it. This is one driver, sorry, one signal. By mistake I have assigned this signal to this value and this value. So if these 3 values are same, then no problem. Here I am getting 1, here I am getting 0, here I am getting 1. So at that time, which value will, sorry, here I am getting 1, here I am getting 0. Now at that time, which value will get assigned here? 1 or 0? We don't know. It will neither a high voltage nor a low voltage. So I will get some voltage in between. So that is what X. From verification point of view. From hardware point of view, I can get any arbitrary number that is not fixed. Okay. So for verification engineer, it is important to capture this X. Okay. But while giving input, okay, I am designing one adder. In adder, I will give some valid input in terms of 0 and 1. I don't need to check my input with X and Z. Output, I need to check whether it is coming X or not. For input, I don't need to give X input. Because X input in practical, we are not going to give. So in SystemVerilog, they have invented 2 value data type. That is only 0 and 1. Here what happens, your simulation time reduces. Initially, it was checking with X and Z. What you are doing, you are randomizing the values. So randomizing means it will be randomizing in terms of X and Z also. But here, if you are doing the randomization, it will simply randomize in terms of 0 and 1. So like this X and Z value, it is decreased. So my simulation time reduced. Okay, so understood about this 4 value data type and 2 value data type?
Yeah, got it, ma'am.
Okay.
Got it. Yeah.
Next, another one data type, logic data type was introduced in SystemVerilog. This is the 4 value data type. All other data types are 2 value. This is the new 4 value data type. Okay. So now what is the use of this logic data type? If you have remember, okay, what happens? This is my module and this is my test bench. Okay. So I need to connect. So let module, this is my input and this is my output. So this is my some test bench signals. I need to connect test bench signal here to here, here to here. So according to your whoever has invented Verilog, they have defined certain port connection rule. So according to the port connection rules, okay, this can be a rich data type as well as wire data type. I don't have any issue. But the output must be connected to only wire data type. If by mistake you are writing this data type as range, then you can get some error. So for verification engineer, design part is not available to them. So you don't know what designers have decided, output, input. You have little bit idea on those things, okay. But there will be so many signals. So every time you are doing the port connection, you have to remember, okay, these signals are input, these signals are output. I have to declare them logic. I have to declare them where. So certain restrictions are there. So to avoid those restrictions, what they have done, no need to declare this as where, no need to declare this as race, simple declare them as logic. This logic data type, it can act as where data type, it can act as range data type. Okay, so you don't have to think about it. So logic data type. So we can do continuous assignment. This continuous assignment in Verilog, it was available to where data type as well as procedural assignment. This procedural assignment, this was available to range data type. So we don't have any issue. So remember in the interface we declare all the input and output signals. So in the interface, we declare the signals as logic. No need to think whether it is input signal, output signal, we should declare as where, we should declare as logic. Sorry, range, we simply declare it as range. But what is one disadvantage here? Only one driver can be connected. It can be driven by only one driver. There is only one driver. So what do you mean by one driver? That means, okay. So like initially I explained you, where means this is a where. This where can be driven by this value as well as this value. I may get a X here, but during compilation, it will not give me any error. That means this where is driven by two values. But if you are declaring it as a logic, so in this kind of scenario, it will give you error. Logic can be driven by only one value. There should be only one value to drive it. Okay, so if your port is input, no problem, you can declare it as a logic. If your port is output, no problem, you can declare it as a logic. But if your input is in-out, if your port is in-out, in-out means it is driven by more than one drivers. It can be driven by in-out means, so input means direction, output means direction will be from here to here. Okay, I'm giving output, this direction is fixed, but in-out means direction can be from here to here, can be from here to here. That means test bench to design, design to test bench. That means two drivers are there. Design can drive it, test bench also can drive it. So whenever your port is in-out port, you cannot declare it as a logic. You have to think other alternatives. But for input and output, you can declare it as a logic. Now my next question is, why we are using logic? We have two value data types. Why we are not using two value data types? The answer is, if we are using two value data type, then we may not be able to capture X. There are certain things where we will be getting output X. If I am connecting a 4 value data type to my output, I can capture the X. But if I'm connecting a 2 value data type to my output, then that X will be converted to 0. So I will not be able to capture it. So logic is required for the output. For the input, you can go with 2 value data type, but for the output, you must use a 4 value data type. Understood?
Yes, ma'am. Yeah, yeah.
Okay. Let me declare it as logic. Okay. So now in this two value data type, what are the things that was included? Okay. One is bit, byte, sortint, This is like C kind of data types. Okay. Short int, long int. Only this bit, it is unsigned. Unsigned means you can store only positive values. Rest all are signed data type. Okay. And you know, I guess you know their size. 1 bit, byte means 7 bit, then 16, then 32, then 64. Okay. In Verilog, there is another data type, integer. Don't confuse int with integer. This integer, it is in Verilog. It is a 4 value. Okay, but whatever int we have in SystemVerilog, that is a 2 value data type. Okay, so now it come, okay, single data type and with vector. You can say this byte, shortened, these are like one dimensional data type. In Verilog also we had one dimensional, maximum to maximum 2 dimensional. But in SystemVerilog we have multi-dimensional data type. Multi-dimensional means next is array. Array means it is collection of similar data types. So first one, go to static array. So static array means during declaration, array size is fixed at the runtime. We cannot change array size. Okay, that means let I'm declaring one array byte, array 1, then I'm writing here 10. So what does this means? Array size is 10. You want this array size, okay, let you have taken here array size some 10,000. Now during the code you have just used 20 memories. Then other memories are wasted even if you are not using, but the moment you declare this array, this memory is allocated to the array. Whether you use it, whether you don't use it, but this like memories got wasted. So if you are not using it, it is wasted. Let in between you need some memory. You cannot add any memory to it. Okay. So as the runtime, we cannot change its size. Okay, we cannot change the array size. So we are moving from array. This is static array, or you can say fixed array, to dynamic array. This dynamic array concept was not in Verilog. Okay. Why dynamic array? Because at the runtime we cannot change the array size. So if we are not using the array, then it is memory wastage. Okay. So next going to dynamic array. Okay. So how to declare the dynamic array? Dynamic array, you have to, if I'm writing byte array 1, then I'm simple leaving these things. Then this is the dynamic array. That means during declaration, I am not fixing its size. During declaration, array size is not there. Now let I am so inside the initial block or inside any function or task, I want to use that array. Okay, so I have to write array 1 equal to new. Then let I want some 20,000 memory. At that time, I know how much memory I need. Okay, so I have written 20,000. Okay, so that means at this point, what will happen? Like what this new function will do, it will create 20,000 memory and initialize all to its default value. Now byte, it is a two-state data type. That means its default value is 0. So it will allocate 20,000 memory and 20,000 0 will be assigned to it. It will do this thing. Okay. Now you want to check the size. So you can write size dot array 1. It will give you the array size. Now let after doing something, you feel that, okay, now I don't need the array. Okay. So you can simply write array 1 dot delete. It will delete the whole array. Okay, So before deleting, at this point, you need, okay, you just think, okay, not 20,000, I need 40,000 values. So you can write array1 equal to new 40,000. So here what will happen? 40,000, same thing will happen. Okay, it will create 40,000 memory and initialize all things to its default value. Now just
Okay,
think.
ma'am.
Now
One
just
doubt,
think.
ma'am.
You ask me.
Suppose we are expanding the memory, will it expand from the place 20,000 ended, or it will be a new heap of memory, ma'am?
That's what I am explaining. Okay, here what will happen? Okay, what is this new function? Let's just go with 2040 so that it will be easy for me to explain. Okay, now let you have some 20 values like 5, 4, 6 like this. You have assigned some 20 values, like you have some valid values stored in your array. Now, whenever you are simple writing new 40, new function work is initialized to its all default values. So whatever the previous value you have stored, it will got lost. So whatever the previous value will be lost. In your language, it will start from 0. Again 0 to 39, new value will got stored. Now,
Okay.
this is not a good thing. I may have some previous values and I need those values. So for that, you can write new 40 with to it array 1. Okay, this syntax I have to check again. I guess with respect to it, I have to add this array 1. Okay, so here what will happen? Previous values. I'm also confused. Either it will be in previous to it or it will be after it. Okay, I will let you know. But here what will happen? The previous values will get stored. Okay, so here it will start from after 21. Now you don't need the array, so you can simply delete the array with the delete. Okay, so this is the advantage with the dynamic array. Okay, so now
on doubt actually, suppose array1 dot is like is it like overlapping?
No, this syntax, no, it will not overlap. What will happen?
So additional for 40 locations, right?
No, total 40 location will be created. What will happen? Here already 20 are there, na? So it will be expand to next 20. That means from 20 location to 39, it will get.
So totally 40.
Total memory will be 40. Okay.
40. Okay. Yeah.
So this is all about your associative array. Sorry, this is your dynamic array. Okay. So now in dynamic array, what is the thing? Okay. Whenever I am writing this new, at that time memory is getting allocated. And another thing, whatever the index is there, that index can be only integer. At some time, I may need some string kind of things. Okay, so at that time, my dynamic array is not going to work. So in dynamic array, one thing you must know these things also, your values are stored sequentially. That means first 0 index, then 1 index, then 2, 3, 4 like this. Okay, but here what is the issue? Okay, the thing is that I am just using here the index that is integer type. Whenever I need some index, I want to store all class data type. Okay, I want that index should be an object type. I want this index should be a string type. Then what will happen? So there is another array they have added, associative. So how to declare this associative array? Simple by array 1. So if I am writing, giving here star, or inside it, this is my associative array. So star means my index can be of any data type. Then here, I am writing string. That means index should be of string data type. Index is string data type. Here index can be any data type. So if I'm writing like this, then it is the associative array. Okay. So in associative array, you don't have to assign any memory. So when memory get allocated? Whenever you are storing any value at that time, memory will get allocated. That means here there is no chance of wastage of memory. Here, even if like I'm given in my dynamic array 20,000, I'm just using 20, I can delete later on. Okay, but the thing is that still there is some chances of wasting the memories. Okay, I can adjust this, I can control this, but still some percent of wasting of memories are in dynamic array. But in associative array, there is no chance of, because whenever you are storing any value, at that time memory will get allocated. Let I want to store 5 values. Okay, array 1. Let here I am giving Sunday. My index is a string type. Okay, Sunday value equal to 20. Now array 2, Monday value equal to 30. So here, okay, now here I have stored only 2 values. So now here for this 1 byte, for this 1 byte, 2 byte memory will get allocated. Whenever I'm not storing any value, there will be no memory to my array. Understood how values got stored in associative array? Okay. Now what is the disadvantage with associative array? In the dynamic array, as I said, values are get stored in sequentially. Let you want to like access all the memories. Let here I have 4,000 memories. 4,000 memories. You want to access all memories. In dynamic array, it's easy. Put it inside a loop, it will assign. It will assess. Because all the memories or all the indexes are sequential. Values got stored sequentially. So I know here value, here there is some value, here there is some value. It happens in dynamic array. But in associative array, values are not stored sequentially. It is stored in a sparse matrix manner. That means one value may get stored here, another value may get stored here, another value may get stored here. So you have to check the indexes because you are storing with respect to indexes. So in associative array, what happens whenever you are accessing some values? Okay, so in associative array, values are not stored in sequential manner, rather than it is stored in sparse matrix. Like haphazardly it is stored. So to access the data, the value, first we have to check the index. Okay, index, and whether in that index value is present or not. So first I have to check, okay, there are 5 indexes. So first I have to check inside the Sunday index whether there is any data or not. Inside the Monday index whether there is any data or not. If there is any data, then access it. But in dynamic array, I know if my array size is 40,000 means 40,000 indexes, values will be there. It may be some valid value or it may be 0 value, but values will be there. Okay, understood the difference between dynamic array and associative array?
Oh, yes, ma'am. Yeah, sure. Okay. Ma'am, before proceeding, I have one basic doubt, ma'am.
Yes.
Let's go. Can you scroll up a little bit?
Yes.
It's about the data type.
Tell me.
Yeah, it's about the logic data type. So I'm used to the regular 2-valued and 4-valued 0, 1x. Is that I do agree. But logic, why was it necessary in SystemVerilog, ma'am?
That's see, I said na, in logic what will happen? See, whenever you are using any where data type. Where data type means you have to do continuous assignment.
Correct.
Range data type means you have to do procedural assignment. You cannot do procedural assignment to where or vice versa. So every time you are doing something, you have to take care. And another main reason is, okay, this kind of connections. This is my duty and this is my test bench. So according to port connection rule, your test bench, signals which are connected to duty output, they must be of where data type.
Okay, ma'am.
Okay, so we tend to do this mistake. Okay, by mistake we may have written this to range, so this may tends to do compilation error. So
okay,
like
okay.
to avoid this confusion, okay, try to think whether it should be where, whether it should be range, just write it logic. You can do continuous assignment, you can do procedural assignment.
So you mean to say that the above side you have one more wire, that register or wire, right? Reg or wire. That part is a mistake. That is a mistake,
no,
right?
this part is important. See here what happens. Okay, let me tell you again. Okay. Where I have written these things. Okay. I have one design part. So module, test, some input 1, input 2, output 1. Okay. So input 1, input 2, output 1. Then end module. According to the port connection rule, this input and input 1, all these things are by default where. Okay, but let you want to declare this output, this is by default where, but you can declare it as range, not a problem. But these things are by default where, no range. By default where cannot be range. This is from design point of view. Again, we have our intention to verification part, because we will be working with verification. I have here 3 signals, some signal 1, signal 2, and signal 3. Now here I have done the instantiation. Okay, so test is my duty. So here I have connected signal 1, signal 2, signal 3. Now by default my signal 3 will be connected to output 1, signal 2 will be connected to input 2, signal 1 will be connected to input 1, right?
Okay, ma'am. Okay.
Now the question is which data type I should declare them. I cannot declare them input and output because my test bench don't have any port. Okay, so what I should declare them, range, where. So according to port connection rule, you can declare them range or can declare them as where also, not a problem. But mostly we'll be declaring as range. Why? Because whatever the values we will be generating now, we'll be generating inside a loop, initial block, always block. Okay, so if I'm using this inside initial block or always block, I may need range data type. Where data type means only I have to write assign S1 equal to 1. This kind of things I have to write.
Yes,
okay. Okay,
yeah,
from a synthesis point of view also I will tell. Okay, from synthesis point of view, let you are writing assign S1 equal to 1. After #10, you are writing assign S1 equal to 0. See, range means it is a register data type. Okay, this is when I am declaring them as where. Okay, range means it is kind of register. You have stored 1 here, 1 will be stored. After 10 nanosecond, you are assigning them to 0. So 1 will get deleted, 0 will be stored. It is not a issue. But whenever you are declaring them as a where, at that time what will happen? 1 means it is permanently connected to 1. Because it is a continuous data type. Continuously it is 1. It is not a range like after 10 if you are assigning to 0 na. After 10 the wire will get confused because 1 is already there. Now you are connecting to 0. So what should I take? Should I take 1? Should I take 0? So it will get assigned to X. So normally constantly I am declaring some values. Let constantly I am connecting S1 to 0. I don't need to change it. So at that time I can take S1 as a where data type. But I want to change some different values, then range data type. But whole I can declare it as range or where, no problem. But this S3 must be a where. You cannot declare them as range. If you are declaring them as a range, then what will happen? You will get this kind of problem. It will give you compilation error. So every time I have to check whether this port is input port, output port. According to that, I have to declare them as range or where, right?
Yeah, understood.
So, if there are so many ports, it will get unnecessary things. So that's why I have taken logic. Okay.
So we can declare everywhere in test bench as logic, ma'am. That's what you're saying.
This logic actually, I will tell where we are declaring this. We are declaring this inside the interface. I will tell. But yeah, you can declare in test bench also. Logic data type, wherever you need a 4-value data type, instead of where or range, it is a good choice to use logic. Whenever you need, you can do assign. This kind of assign statement you can use. Whenever you need, you can do blocking or non-blocking assignment. You can use logic. But what is the limitation of logic? It is driven by only one value. Let your signal need to be driven by 2 values. Let you have a port that is in-out port. At that time, you cannot use it as a logic, right? Because it is the in-out port.
Yeah.
So at that time, you have to think where or range. But other part, you can do logic.
Okay, ma'am. Yeah, got it.
Yeah, so now I can come to here. So now I have explained to you dynamic data type and associative data type. So now my question is when to use where data type. Okay, fixed array. We understood fixed array for small memory 5, 10, 12, 15, this kind of memory we can use fixed array. If my memory size is large, then I should go for dynamic or associative array. Now my next question is when to use dynamic array, when to use associative array. Can you think anything like when to use which array?
When do you use what, ma'am?
When we should go for dynamic array, when we should go for associative array.
Okay, so let me try. When we are sure about we want the locations consecutively, we can go. We must declare a static array.
Yes. No, static.
So, but we don't know when we wanted in consecutive manner. That I don't know, ma'am.
Okay. See, static array when practically we'll be using less static array. Why? Because obviously we are not going to deal just small memories. If my memory size is 10, 15, 20 like this, I can go for static array. Because even if there is some array wastage, it is not an issue. But static array we should avoid as much as possible because in between, if I need some extra spaces, I cannot do with static array. So my answer will be like if memory size is large, then go for either dynamic or associative array. So now my question is okay. Next, when to dynamic and when to associative. Okay. Now let you know exactly your data size. Okay. You know exact data size. Then go for dynamic. Because you know though, you are sure about the data size. Okay. Now you are not sure about data size. You don't know how many packets you are going to receive. Not sure about data size. Then obviously you have to go for associative because in associative, as long as I am storing the values, it will keep on storing the values and it will keep on allocating the memories.
Yes, ma'am. Yeah, got it.
Okay. Now you know the data size. Okay. And one is said, you are going to access all the memories. You are going to access all the memories. That means let I have 5 GB of memory. I need to access all 5 GB of memory. Then I should go for dynamic array. Why? Because in dynamic array, search will be done sequentially. So it will not take much time. But in associative array, values are not stored sequentially. It will first check whether in that index values are there or not. Then only it will return the value. So it will take time. So if you want to access all the memories, then go for dynamic array. Understood this point?
Yes, ma'am. Got it.
You are going to access all the memories dynamic array. Why? Because in associative array, it will take much time. It need to check first whether data is present or not. Now
dynamic array, but associative array means we should be able to get access in a short time. Actually, that's what.
Why short time? Okay. Why are you thinking it will take short time?
Why? Because no. Suppose if I go by array method in a regular index method, then I have to give the increment value of indexing 0 to whatever value.
Okay, just take 20 values. Okay. It will start from 0. No problem. 0, 1, 2, 3, 4, 5, 6. It will up to go to 20. If it is
No,
20,
for reaching no, ma'am, for reaching to that algorithmically, what we'll do, we'll put a for loop and access in the numeric index, right, ma'am?
Yes, yes.
So for going to the 1000th position, then I have to increment 1000 times, ma'am, for
Yes.
going there.
Yes.
Whereas in associative, whenever I say array of 10,000, then it will go and fetch there directly.
No. See, okay, dynamic array, whatever said, you are correct. Okay, but in associative array, you have written array. Okay, let's just take a index of numeric point of view. In dynamic array, it will be 0, it will be 1, it will be 2, no problem. But in associative array, this index may be 0, this index may be 1, this index may be 2.
Correct.
So whenever
correct.
you are writing index 0, it will first search where is my index 0. Okay, my index 0 is here. Then it will return the value. Where is my index 2? Okay, index 2 is at the end. It will go and check.
Actually, let's say take an example like array of, let's say this is a associative array of some particular data type. Let's say names, array of names, ma'am. So
okay, now here remember, okay. Okay, array of names means you are going to store the values in the name. Like here it is string data type.
Yeah, correct.
Or indexes are string data type.
Index, let us keep some other data type, ma'am. Like what do you say?
Indexes
like,
are numeric and values
ID, like as if it's a school database, no? Like what they will do, they'll set one ID actually, student ID.
Exactly. And okay, here, okay, now that I was going to tell only, okay, here, okay, let me complete this. If data types are, sorry, indexes are other than numeric, then go for associative array. Now, whatever you are saying, student database I need to store. Why should go to
that is
dynamic
numeric,
array?
numeric, yeah. That is numeric.
No. For student, you are going to store in student roll number or student name?
No, student name I want to store, ma'am. But
so now
what is the unique key? What is the key value I'm going to give that data type of key value?
Okay, see, okay, here let me tell you, key value depends on you. But now here see, student, I'm storing the values in some array. So array 1 of, let student 1. So whatever the values you can store here.
Yeah.
Array 2 of student 2. Whatever the values you can store here. So here I should go for associative array, but now you're saying, no, I don't want to store in terms of student 1. I will be simple storing with respect to their roll number. So here it's up to you. You student 1, student 2.
No, whichever the question was, which is
I
faster,
will explain. Okay, first let me explain these things, then you can ask your doubt. Okay, now you are saying, no, I want to store them with respect to their roll number. Then first array 2 of 0. Okay, then array 2 of 1. Like this you have to store. Okay, now here let you want student 39. You want to, okay, there are total 40 students. Okay, so now you want to check all 40 student data values. Okay, so you are stored in terms of their roll number. Okay, so now you want to check all 40 values. So you can put inside a for loop. That for loop will run.
Correct. That's what I'm saying. So suppose I want to access the 40th member, means I have to traverse all the way. Even if I'm not interested in 0, 1, I have to anyway increment.
No, simple. You can write array 2 of 40. No need to travel all these things. It will give you the
like
40
that,
values. It will give you 40 values only. Okay, whatever you are saying.
Index value. No. For index value to increment to 40, right? That one I'm saying.
No. What you are saying, you are showing assessing all the values. You want to assess from 0 to 40. You have to increment, but
we have to give.
Just want
directly here also we can give like this. Okay.
What is the 40 value? You need to check array of 40. It will go to 40 index and give the values. And here for this associative array and dynamic array are same. You want to check what is inside student 2, array of student 2. It will give you all the memory. If there is no thing stored, it will return you 0. If there is any value stored, it will return those values. So no problem. But what
Okay,
I'm
so
saying,
I understand your point, ma'am. I understand your point. So you're saying that because it is consecutive locations, so we are able to access faster. Whereas in associative array, it won't be consecutive, so it will be slower.
exactly,
That's what you're saying, right?
It will be slower. Okay, correct.
Got it.
Whatever you said. Okay. So now, whenever you want to access all the memories, then go for dynamic array. Even if you don't know the exact data size, but still go for dynamic array. So depending on this situation, you can decide. Let in some like protocol now, we have some ID attached with them. So for those kind of things, it is better to go for associative array. Values will get stored with respect to IDs. First,
Okay,
let
ma'am.
30 ID come. So in 30 ID, value will get stored. Let then come some 12 ID. So with respect to 12 ID, values will get stored. If there is some ID kind of thing, it is good to use associative array, because dynamic array means it will start from 0. Okay. So in associative array also, we have some methods. Okay. So see, if you go through the document that I have provided for SystemVerilog, after each kind of things, I have done small coding, because all the things we need in terms of code. This is the dynamic array. Okay. Here, I guess whatever I explained you. What is okay? This will be like this, I guess. New 40, then array 1. Okay. Like this, huh? New 16, array 1. So here, whatever the previous value, that will get stored. Okay, so you can write this small code and you can check how the outputs are coming. Okay, so whatever the things I have given you here, na, to like first proceed on these things, you should have knowledge on arrays. Okay. Sorry. So in associative array, and these are some methods that we should remember. Whenever we are doing some operations with the array, we may need some inbuilt methods. So these are some inbuilt methods are there in the array. These are easy, you just have to remember their name. Okay, from name only you can learn what can be. Okay, so this is my associative array. So see here, data will be stored like this. With respect to 10, 9 stored, 7 index, 3 stored, 0 index, 5 stored, 1 index, 7 stored. So here, this red signals means my address is not conjugative or not
Yes,
sequentially.
yeah.
Now these are some methods to check the size of the array. To delete, let it particular index you want to delete the array. So delete index. At particular index you want to check whether there is any value there or not. Then this one. So what is your first index? You don't have any clue now what value is stored first, which value is stored last, because you stored all the values with respect to index. You want to check, okay, so first value, it will give you this. What is the first index stored? What is the last value get stored? You can get here. In dynamic array, you don't need this, because first means 0, last means array size -1. That will be your last index. Then let you.
Ma'am,
Yes?
suppose ma'am, one question. Suppose I want to print all the associative array data values. I want to fetch all the values, means I have to use next like that, ma'am.
Next. This one you have to use. In the
next
loop,
and previous, like. Okay, ma'am.
in the loop, you have to use next. Okay, just 1
Okay,
minute. I'm getting a call. Okay.
Yes, ma'am. Yeah, got it, ma'am.
Okay. Hello.
Yes, ma'am. Yeah.
Now let you want to access 20 values. So 20, next you have to do. Okay.
Okay, ma'am. Okay.
So previous values. Okay. Now here see, to store the values, I have to use this. There is no index. Like you have to mention the index, with respect to index, values will get stored. Okay, but in dynamic array, we can simply use a for or for each loop, and we can increment the index. Index will get increment, and values will get stored. Okay. So whatever the things I have provided you here, okay, if you are working with those assignments, then you will get to know how to use those things, how to use an array, because mostly you will be using array data types only. Okay. So now, so this
Okay, ma'am.
dynamic array, associative array completed. Next, they have introduced another kind of array that is known as queue. So what is the advantage of queue? Its size. Okay, size can grow or shrink, add element anywhere. In dynamic array, adding element anywhere not possible, because sequentially we have to add. First one location, then 2, then 3, then 4, like this. Let what you want after 4, you just want to add any values like fast, you know. Okay.
Yeah.
Let you have assigned up to this, then you want some values to get assigned here, like in fast. In dynamic array, it is not possible. In associative array, it is possible because we are storing the values with respect to index. So with any index, I can store the values. Again, in associative array, the problem is that I cannot travel sequentially. So to mix these things, they have designed queue. Queue means you can add data. You need to add data here, you can add data here. You need to add data here, you can add data here. Not a problem.
That is, ma'am, that is in dynamic array, or you're telling that in associative?
Queue.
Associative
No,
queues.
this is another data type, queue.
Oh, I see.
Okay. So I was saying, what is the demerit and of dynamic and associative array? There should be certain limitation. Na? That's why we are moving to queue.
Yes.
So the limitation is that both the array, it cannot, like if we want to add index in some particular position.
Correct.
And delete something. Okay. We can do in associative array, but the thing is that associative array, we cannot travel sequentially. So in queue, we can add element anywhere, we can delete element anywhere, and we can travel sequentially. Values are getting stored sequentially. Okay. And indexes are
another method you already told, ma'am, that new this one was there, no? That is another method, right? See, one way of growing the dynamic array.
Okay,
is
growing the dynamic array, but there what is happening? The values, okay, after this, values will get added here. Now let you want to store any values initially.
Oh, in the front we can't do. Correct.
Okay, so for that we are using this queue data type. So in queue data type, it is like FIFO, LIFO, first in, first out, last in, first out. All those things you can do with respect to a queue. So whenever we are verifying FIFO will be almost in every project. Okay, so whenever we are verifying FIFO, it is very easy to use this queue data type. We just have to write 3 to 4 lines of code for FIFO. Okay, so in queue, okay, so see size, insert a value. Here you have to give index with respect. It is like associative array. Insert index, then delete index. Push front means it will give the values from the front size. Push back means it will insert the values from the back size. In dynamic array, push back possible, but push front is not there. But in queue, push back, push front, both are there. So pop front means you are deleting. So whenever we are getting the values, pop means it will decrease the array size. In dynamic array, let you want to check what is in your 0th location. Let after doing some operation, you feel that 0 to 10 location I don't need. I need just 10 to 20 location. You cannot delete only 0 to 10 location. Why? Delete means you have to delete the whole array. But in queue, it is possible to delete 0 to 10th location. Okay. In dynamic array, it is possible to delete all the location. Here only one location, it is possible to delete. So here, this is push back, push front, pop back, pop front.
Okay. Yeah.
You should know how to use these things. Just at least one thing. Okay.
Yes, ma'am. Sure.
So this is all data type. Okay. This I just explained in terms of data type. Okay. So this is like similar kind of data type completed. Okay. This all arrays means similar kind of data type. Let you need to store different kind of data types. Then we have structure, struct, union, class. So next, when to use what? Okay, struct means it is static. Okay, struct and union, these both are static. Okay, so structure. Okay, so struct, it is static, and here you can store only data types. No task or function. In union also same thing. Static, store different data types. Okay. No task or function. Then when to use struct, when to use union, let inside the struct the memory equal to addition of sum of all data type memory. Okay, but in union, your memory will be maximum of all data type memory. That means at a time, you cannot use all the values. Let you have stored 1 byte and bit and int data type. Okay. So now in the structure, how much memory will get assigned? For int 32, for bit 1, 32 plus 1, 33, plus byte 8. So 33 plus 8, 41 memory will get assigned. So here you can use at a time byte, bit, int. Now in union, how much memory will get assigned? Only 32, because maximum is 32. So at a time you can use byte, bit, not a problem, because it comes under 32 memory. But if you want to use int and bit data type, you cannot use, because it need 33 memory, but you have only 32 memories. So whenever this kind of scenario, you can use union, else you can use struct. Understood?
Yes, ma'am. I got some disturbance here, so I will go through it, ma'am.
Okay.
I mean,
So
it'll be. You can share it after the thing also.
Yeah, I'll share it. Okay.
Okay.
Now next it is a class. So class, it is dynamic part. Okay, so this is the main advantage, dynamic. Static means we cannot delete those things. Once it is present means it will be present. So it is dynamic, plus you can store different data types. Plus methods. Okay. So this is the like from the Verilog to SystemVerilog. I have just explained in terms of data types. Okay, there are other points also. Okay, those points I will be explaining in the next class. Okay, because there are so many things why we are moving from Verilog to SystemVerilog. This is only the data type. Okay, there are other things also. Okay, so next is, okay, here let me just explain one code. Next, if you can like this, you can try other code. Okay. So here, okay, so
ma'am, you leave it. This we can. I'll try it and I'll come back to you. If any questions, I'll ask.
Just let me explain. Okay, so if you one more thing, okay, you can do just before going to those things. Now here, how to use the array. I want to assign some values to the array. Okay, so in dynamic array, I have written some code. Memory initialization. These things. How to use for each loop. This is manually doing the initialization. This is by for each loop. So just know these things. Let I have an array of 30 memory size. I want to assign some random values to it. How can I do it? Just go through this. Tomorrow we'll be discussing these things plus rest reasons why we are moving to SystemVerilog. Okay.
Okay, ma'am. Sure, ma'am.
Okay. Bye.
Okay. Thanks a lot, ma'am. This. Hello? You'll be able to share, ma'am, this one?
Yeah, I will share.